Okay, so this video starts part 2 of solving equations by factoring, and we're going to be working with when the different terms have a common factor. So let's take a look at this first example. We have 6x squared minus 21x minus 45. Now, this is not 1 in front or no number in front, so we have to try to see what common factors each of these terms have. And probably the easiest way to do that is to list them. So we're going to write 6 and 21 and 45. Now let's try to think about what times what is 6, right? We have 1 and 6, and we have 2 and 3. I'm going to think of 2 and 3, right? And 2 times 3 was going to give me 6, right? 21 is 7 times 3. And 45 is 9 times 5. Now, all of these have so far no common factors, but I know I can break down that 9 into 3 times 3 times 5. So when I look at it, I have 3, 3, and 3. Now, another way to do this is we can make factor trees, which I think also is pretty simple. So we can say 2 times 3 gives me 6, 21, 7 times 3, right? And then 45, 9 times 5, but I can still break down more 9 into the prime numbers, which is 3 times 3. And of these, again, we go back and 3, 3, and 3 have in common. That means that I can take away a 3 or factor out a 3 from all these terms, and I'm still left with a coefficient or a number for the final term. So we're going to factor out a 3. And we're going to be left with, on the 6, 2x squared, with the 21 minus 7x. There's still that negative there. And then minus 15. Okay? Now, why do we do this? A lot of times we get lucky and it factors out the complete number of that first coefficient, the leading coefficient of that x squared. And then all of a sudden it makes factoring a lot easier. But sometimes it doesn't work out. What does happen in those cases is you have smaller numbers to deal with, and it's easier to multiply them together and manipulate them because they're just smaller, easier to multiply. So we have our factored out common factor. We're going to leave that as a 3, and I'm going to create parentheses now. 1 and 2. Now, these are equal to 0. Sorry, I forgot that. And now let's try. Now, I'm going to take a look at this really closely. Let me see the pencil here, just so we can move around and I can erase. But here's the interesting thing. So we have negative 15, all right? Well, the possible combinations of negative 15 are negative 3 times 5, right? Or 5 times negative 3, or negative 1 times 15, or positive 1 times negative 15. All of these work to create and to fulfill or anyway, to create negative 15. But we have to look at our middle term and take a look. That middle term, first, I looked at its negative. That tells me that whatever I'm putting in these terms, what creates a negative number is going to have to be the larger of the two. So let's start with the easy stuff. Let's start with the 2x squared. Oh, wow. Oh, my goodness. I just realized I write this as 2. Sorry about that. I'm sorry, 3. Never mind. Forget about that. Anyway, so we're going to do 2x times x. Okay? So here goes. Now, I want this to be, right? This is going to give me, let's see, took out a 3. I'm left with 15. All right, now I got to create that 15, right? So I want the middle one to be a negative 9. If I put this, see where my larger number 2, and this is sort of a 1 that's being held there, but you don't really need to write it down. I want to, whether I use the combination of 3 and 5 or 15 and 1, I really want this to be minus either 15 or 5, the two larger numbers of these combinations. I'm going to go with 5 because 5 is a lot closer to the number 7. So I'm going to try 5. Now, what's left? If this is negative 5, right? Sorry about that. Okay. If this is, okay, and this would be, sorry, negative 5 times 3, right? If this is negative 5, the other one, because it's negative 15, should be positive 3. Okay, so those are our combinations. Let's see what we get. Now, first, we find 3 times negative 15, I'll say it again. 3 times negative 5 is negative 15. That satisfies that. So we're cool there. Now let's look at our middle terms. This and this one is 3x. This times this one, negative 10x. Okay, all good. Well, like I said, if I have $3 and I owe someone 10, I pay with my $3, I still owe them negative 7x. And there it is. My middle term satisfies the last term and the middle term. And I'm good to go. All right, so let's rewrite it down here, and we're going to find the solution. 2x plus 3, x minus 5 equals 0. All right, solutions. First of all, 3 does not equal 0. This is not a solution. Now, we'll try another one. Any one of these, when they become 0, make the whole thing 0. So 3 cannot become 0. It's not a solution. Now we're going to try 2x plus 3 equals 0. Okay. Well, we're going to subtract 3 using the subtraction property of equality. And we get 2x is negative 3. And we divide both sides using division property of equality. And we get x equals negative 3 over 2. That's one of our solutions. Another solution. So if this, to make this 0, we would substitute the x by negative 3 over 2, and it would create negative 3 plus 3, which is 0. Now, next we're going to do x minus 5, a little simpler, equals 0. We use addition property of equality on both sides. X equals 5. So when I put 5 here, 5 minus 5 is 0. It won't make a 0 here, but will here, and that makes the whole thing 0. And those are our two solutions for this example. And that is how you factor out a common factor. Now, it's really important. I'm going to give another example here of one that I think is super important. So I'm going to wait a few seconds. Okay, so you can kind of look at it. And we're going to do example number 2. Here we go. Example 2. We have negative 5x squared plus 8x plus 4. All right. Now, this one has a negative 5 in front. And really, when we think about 5, 8, and 4, 5, if I were to do a factor tree, is 1 times 5. 8 is 2 times 2 times 2. 4 times 2 gives us 8. And 4 is 2 times 2. Now, 4 and 8 have 2 and 2, 2 and 2 in common. That's a common factor. But 1 and 5, nothing, right? 1, they all have 1 there, even if you don't write it. So 5, there's no 5 here. So there's nothing as far as numbers go that we can factor out of this. But I highly, highly recommend to all my students that when you have the leading coefficient as negative, 5, negative 2, whatever it may be, even if you can't factor out the number, I would factor out the negative. Because maybe it's something that we as humans have, I don't know what to tell you, but those negatives are super easy to make mistakes. They're little, they're easy to forget. When you're trying to work something out quickly, a lot of people make their mistakes on negatives, and I am one of them. So in order to kind of get rid of that, especially in that beginning leading coefficient, I'm going to factor out negative 1. And I'm going to get 5x squared, and I basically change the sign of everything behind it. This becomes negative 8x, and that becomes, sorry, I did write a 2, but it's really a 4. Okay, I'm going to rewrite it here. Okay, so now we have the leading coefficient as positive, which is a little easier to deal with. So we're going to create 2 parentheses because they have no common factors. Now, I'm going to write 5x, and I'm going to write x. Setup. Now, let's look at our middle term. This one is negative. So that means the largest number, the 5, should multiply by a negative number to create a negative in the middle. So let's think about this. This is 5 times x, 5x times x. That creates 5x squared, right? So let's take out our trusty pencil because we may be erasing a little bit. And let's see, what would I multiply to get negative 4? It could be negative 4 times 1. It could be 4 times negative 1. It could be 2 times negative 2 or negative 2 times 2. Those are our basic combinations. Now, we have a negative 8. I am going to pair up because what you're multiplying to get the middle term is these two and these two. So the ones I'm thinking of pairing up is the negative 4 with the 5. And then this with the 1x. So what do we get? We get 5x times negative 4. I'll write it here. 5x times negative 4, negative 20x. Way out there. No way. So let's try another one. And I still want to go with my bigger number to be attached or matched with that 5x because the negative number is bigger. So we tried 4 and 1 or negative 4 and 1. So let's try the 5x with negative 2 and this with 2. Okay, let's see what happens. So we're going to start with the middle first. 2 times negative 2, you got it. That's the last term. 2 times negative 2, we met that. Now, 2x, I like to call it rainbows and happy faces, 2x, and negative 10x. We got negative 8x. And whoa, we got the second one. We made the first requirement and the second requirement. That's what it is. Now, how do we find the solution? And sorry about that, but this should be equal to 0. Okay? So if this parentheses is 0, the whole thing becomes 0. And if this parentheses is 0, the whole thing becomes 0. So we're going to go ahead and, I'm going to use a different color, purple. 5x minus 2 equals 0. I use the addition property of equality, and I get 5x equals 2. Divide by 5, both sides, division property of equality, x equals 2 over 5. Okay? And I just realized something. I just ate a negative. Let's fix that. So this should be 5x plus 2. So that means I'm subtracting both sides by 2. All right? Let's make a bigger subtraction sign. What a mess. Anyway, we get negative 2 over 5. Negative 2 over 5. See how easy that is to happen? You know how no matter how many times you do it, those negatives are very easy to mess up on. So x minus 2, I'll do this in red, equals 0. We're going to use addition property of equality. We add 2 to both sides, x equals 2. And those are my two zeros. On my graph, if I was graphing this parabola, I know on the x, I would have 2, and I would have negative 2 over 5. I find my middle, and I'm almost pretty much done for graphing it. But these are the two solutions, the two zeros to this. We factored it, we found the zeros, and that is basically, how you do this when you have a common factor.